Okay, so for the PT group, you can mark attendance now. Okay, for the PT20, wait for a while. Yeah. Okay, yeah. So now you can mark attendance for the PT20. Okay, so now for the ODL, you can mark attendance now. Yeah. Okay, so now what we do, okay, any question you want to ask for the previous discussion? Yes. It means for the multiple discriminant. Yeah. Okay. 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 So now I answer the question. When checking the normality, you must make sure checking for what normality? Yeah, for univariate or multivariate? Okay. Uh, Univariate or multivariate?
So let's say we check the normality of the residual. So does this hypothesis also consider one of these
No,
the three of these hypotheses?
No. Okay, because you check the normality of the residual, actually it's only the testing on the assumption, not considered objective. Yeah. Okay. Okay. Yeah. So.
So, sir, for this multiple discriminant, so what we conclude is we use the potency index to find out the discriminants rather than the stepwise. Stepwise is just a reference, right? We don't use stepwise.
Not like that. you cannot compare like this. If you say that we use we use the simultaneous method, means we include all the specified, all the predetermined independent variables. So stepwise, can you see you compare this way, not compare stepwise with the potency. Okay, not like that. Okay, now.
Okay, so in the end, the discriminant of two methods could be different, right?
Yeah, could be different also, but we already discussed one method. I think it's already good enough, lah. Okay, yeah.
Potency one.
Okay, yeah. Okay. Okay, yeah. Good question. Thank you. Actually, not much. I cannot comment too much on Mr. Lau's. Okay, so far not many people teach this module. So far only 3. No, 4. Okay. I do moderate Mr. Lau's module, MMDA. Yeah, I can say that passing rate is above 90%. Okay, passing rate above 90% for this module. Yeah. Okay, including his module and also my module. Okay, second time I'm teaching this. I mean for you, it's second time. So yeah, my first time also 90%. About that. Yeah, about that. Okay, this is a historical experience. Yeah. Okay, so but I cannot remember exactly how many percent. But of course I do moderate his paper. Okay, yeah. So can give you advice also, a bit advice. Normally, I mean for my module, of course passing rate is 90%, but certain, I mean the passing rate for the test only 80%. Can you see? Means some students they rely on the quiz and assignment to pass them. So therefore, you try to allocate more time to do the test, because uh, test 4 questions, 100 marks. Therefore, maybe that's why you need to study more. You have more topics compared to the quiz. And also assignment you can prepare. You got more time to prepare. You're more flexible. Okay. Maybe that's why the test passing rate is quite lower, a bit lower, but still got 80%. About that. Okay. Okay. So yeah. Okay. Okay. So if no other question, now what we do, we can discuss new chapter. Okay, now, yeah. Okay, wait, Adam. Okay. 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 So now we see logistic. Okay. So logistic is there are some part quite similar with the multiple linear regression. Okay, because of the regression. Okay, quite similar. Yeah. But there are also certain part quite similar with the multiple discriminant. Yeah, because we also can find the hit ratio. Yeah, using the what they call the logistic. Okay. Okay. You see the learning objective. So you should be able to state the circumstances under which logistic should be used, yeah, instead of multiple regression. Yeah, of course, because of the dependent. Yeah, dependent must be only 0 and 1. Okay, so we can use the logistic. Yeah, and you should not use the multiple linear regression if this one happen. Okay. And because the dependent is only 0, 1, we call it, but some textbook call it binary. Okay, binary logistic regression. Okay. So actually there are also other logistic regression, but they use multiple category, means 3 or 4 category. But for us, we only discuss the binary, okay, in this module. Okay. So, and because of the dependent variable change, therefore a lot of things also change. Example, the interpretation. Okay. Example, you can find the hit ratio under the logistic, but we cannot find the hit ratio under the multiple linear regression. Different. Okay. Okay. So the different type of dependent and independent variables used in the application of the logistic regression. Okay, means here is apply. Okay, apply in your real life. Okay. Okay. So describe the method used to transform binary measure into the likelihood and also probability measure used in the logistic. Example. So what we do here also a bit different compared to many things, compared to the multiple and also the multiple discriminant analysis. Example, here we can find the probability. Okay, so example probability. Okay, try to use a bit different example. Okay. Okay. So okay, it's okay. We can say probability of affected by the COVID. Okay. Yeah. Okay, by COVID-19. Can you see? Yeah. So this is therefore can be 1 and 0. This is affected, this one not affected, means never. So far never. Okay. Therefore, so here it must be only 1 and 0. Means you can consider infected 1 or 2 times. Also consider infected. Okay, this is never. Okay, therefore 0 and 1. You can compute the probability that the person infected the COVID before, like that. Okay. Okay. So here, binary measure, we're going to consider it, convert it to the likelihood and probability. Actually, probability is also likelihood, same thing. Okay. Yeah, in the logistic regression. Okay.
Sir, when we talk about 1 and 0, are we talking about dummy variable?
Good question. Good question. So okay. Okay. You actually asking two questions. Yeah. It's okay. You ask one question, but I can answer you in two perspectives. Okay. So first thing, the dummy variable that we discussed in the multiple linear regression actually is for the independent variable. Okay. But now under the logistic, yeah, the 1, 0 actually is under the dependent. That's the total different thing. Okay, that's the first point. Okay, any question? Yes.
Yep, so far so good.
Okay. Okay. So okay. And then second thing is about the interpretation. Okay. Second difference is on the impact of the dummy. Okay. Impact of the binary. 1, 0. Okay. Under the multiple linear regression, when we use dummy, we are going to get two equations. Okay, but here is different. We are not going to get two equations, but we are going to introduce we call it odd ratio. Okay, means we are going to use odd ratio to handle the dummy. Yeah, as I said, binary is more better. Dummy we always refer to the multiple linear regression. Okay, but binary logistic regression, so we use odd ratio to handle it. Means it will be like this. Okay, yeah, like this. Okay. Okay, like this. So we call this odds ratio. Okay. Basically, we want to find the probability. Yeah, probability that something happened. Example, probability just now, probability that the person infected by COVID before, means at least once. Okay, the classical example that I use a few times is probability that a person own a house. Okay, like that. Okay, so own a house, of course you can make it very clear. Correct? After sign the agreement, consider, I mean S&P, you still consider, already consider own a house. Okay, like that. Okay, so different thing. That's why I say I can answer you in two perspective. Okay. Okay.
Okay, thanks. Thanks.
Thank you. Now we see next. Yeah. Okay. So we can objective, you should be able to interpret the result of the logistic regression analysis and also assessing the predictive accuracy. Can you see? This part is the same with the multiple discriminant analysis. Here the hit ratio, remember? Okay. This part is the same thing. Okay. So, and then we can compare it to the both multiple regression and also the discriminant analysis. Okay. For certain part same, certain part different. Okay. So, okay. Example in the we compare if the multiple regression, we can substitute. Where is it? We can yes, correct. We are here. Okay. We can substitute the x1 and x2 to find the p. P is the probability. Okay, of owning a house or infected COVID-19 before. Okay, so this part is quite similar with the multiple linear regression. Okay, but about the hit ratio is similar with the multiple multiple discriminant analysis. Okay, okay, because the individual may be also correctly or wrongly classified. Let's say own a house and actually predicted own the house, actually also own a house, means it's good lah. But let's say they not own a house, but predicted own a house, it's not correct, misclassified. Okay, yeah. Okay, so first we also should discuss the strengths, yeah, and the weaknesses of the logistic compared to the discriminant analysis and also the multiple regression. So you can compare if these two. Okay. Okay, so question. Okay, now we see next. Yeah. So now we are here. Yeah. Okay. So logistic regression is a specialized form of regression. Okay. So therefore, it's like this. Multiple linear regression, like this. Okay. So this is logistic. Okay. So these are other things, but this is logistic. Okay. One of the special case, yeah, under the multiple linear regression. Okay. So we see that is designed to predict and explain a binary. Can you see two groups of categorical variables? Yeah, means we are going to explain the categorical variable. The categorical means 1 and 0. Yeah. Okay. Here must use 1 and 0. You cannot use 1 and 2. Cannot. Okay. Okay. So and then not means not a metric dependent. If your dependent is metric, you should use multiple linear regression. But now it's not. Okay, it's categorical variable. Okay. It's variate. Yeah, means right side. Okay, you see this right side is the similar. Can you see? This side is quite similar with the multiple linear regression. Okay, but the left side is different. Okay. Okay. Okay, is similar and then make up of the metric independent variables. Therefore, in this context, it's quite similar with the multiple discriminant because the left side categorical, dependent categorical, and then the right side is metric. Okay, so therefore looks like quite similar with the discriminant also. Okay. Okay, if no question, we see next. Yeah. Okay. Is less affected than discriminant analysis when the basic assumption, particularly normality, are not met. Okay, meaning that if the data is not normal, still okay. Okay, yeah, still not much problem. Yeah, therefore less affected compared to the discriminant analysis. Okay. Okay. Logistic regression may be preferred when the dependent variable has only two groups. Can see again, important, cannot be 3, cannot be 4. Okay, so logistic regression may be preferred for two reasons. Discriminant analysis assumes multivariate normality, yeah, but this one no. Okay, and equal variance, yeah, equal variance covariance matrix across the group. So remember box M, okay, and also the Maha law bis, okay. But here no need, okay. And these assumptions are often not made. Okay, logistic regression does not require these strict assumptions. Therefore, it's much more robust. Yeah, when these assumptions are not made, means even they not meet these two assumptions, but we still can proceed using the logistic. Okay, therefore can be applicable in many situations. Okay. Even if the assumptions are made, some researchers prefer logistic regression because it's similar to the multiple regression. Okay. So means you make assumption, therefore you are more flexible. You can choose discriminant or logistic. Okay. But first, again, a different objective. Okay. So, but looks like logistic is a bit better, a bit stronger because they can find the hit ratio. You see. They can find the hit ratio, also they can do the find the probability, right? Probability of infected by COVID-19. The probability owning a luxury car. Of course, you can define the luxury car by your own. Okay. So okay. It has straightforward statistical tests. It has similar approaches to incorporating the metric and non-metric variables, a non-linear effect and wide range of diagnostics. Okay. Therefore, it's quite similar. In this sense, it's quite similar with the multiple regression. Okay. So actually also including the t-test. We can also do t-test using logistics. Okay. Okay. Any question? Yes.
Sir, can I say that the logistic regression is more on it's similar like MLR is like doing a cause and effect rather than classifications like MDA?
Actually, you're correct. It's more similar to the multiple regression, but also can do classification. Therefore,
both also can.
Yeah.
Okay.
Because you can find hit ratio. Remember, the predictive accuracy. Yeah.
Okay.
Yeah. Okay. So therefore, it's better. Okay. So next. Okay.
Oh, sorry, sir. Can I ask you one question? Multiple linear regression, we can use it to do prediction. And MDA, can we use it for prediction?
MDA.
The discriminant analysis.
Yeah, can.
How?
But more general. It will be more general. Right?
But it's mainly for classification purpose only, right? Not really.
Classification and also predictive accuracy.
Or predictive accuracy. But
Let's
for
say,
this,
let's say the predictive accuracy is low. It's low. Therefore, means the model not too reliable, not convincing.
so for LR, we also can use it for prediction purposes as well.
Yes, correct.
Thank you, sir.
Yeah, thank you. Okay. Okay, so continue. So the decision process, okay, we need to do the objective, okay, research design, okay, assumption, okay, estimation, and then also the interpretation, and also validation. Okay, these are quite standard steps. Okay, so of course you will see odd ratio. Something is a little bit, it's quite different. Yeah, for this logistic compared to others. Okay, odd ratio. Okay, we see now. Yeah. Okay. So this is the best suited to address two research objectives. Identify the independent variable that impact the group membership. Can I say that impact the group membership in the dependent variable? In this case, we can do it also using the MDA. Okay, but of course, in MDA is still a bit better because MDA can do it for 3 or 4 groups, but logistic only 2. Okay, cannot be more than that. Maximum 2. Yeah, if 3 cannot. Okay, like that. Okay, so but first, this also one advantage for the logistic, means easy to do the calculation. Okay, so you can establish a classification system. Yeah, based on the logistic model and determine the group membership. This is easier as compared to the discriminant. Okay, so in terms of doing prediction, this is easier for us to do it using the logistic as compared to the discriminant. Okay. Okay. Confirm ah? No question.
Sir,
Yeah.
if I want to make it simpler, so I should because when I look at it, the logistic regression seems like more powerful than MDA, right? So if I want to use logistic regression, so what I can do is I will break the groups into two, merge the group into 2 groups. So if I have 4 groups, for example, I merge it into 2 groups, then I can use logistic regression, and will it give a more meaningful, output?
Okay. Good question. Okay, good question. So in the I know a question. Okay, good. You are saying that you got 4 groups. Okay, 1, 2, 3, 4, and then you're supposed to do MDA. But now what you do, you convert these 2, become one group, group A, group B. After this, you do logistic. Okay, correct? Something like that.
Yes.
Okay. Then, if like this, we can do a lot of things. Yeah, but you must know also this category meaningful or not meaningful. Okay. So example, for our case, income still can be used. Therefore, A can be low income, B can be high income. Okay. But let's say if 2 and 3 are quite similar, means this category may not be good. Can I see? Example 2 and 3 are quite similar. Okay, but therefore 4 group still okay. But you purposely make it 1, 2, 1 group, 2, 3, 4, 1 group. Therefore, may affect the result. Maybe the result not too good or what. Okay. Okay, so this is a concern. Yeah, you need to know what context. Can I say? Yeah.
So can I say that MDA I can predict more specific compared to this logistic, because logistic only have 2 outcome only, but MDA can be more specific. If I want to have more outcome, I want to get the specific one. MDA will be more accurate, right?
MDA more accurate because it got 4 groups.
Yes.
4 group. I was saying that 4
income
group
level,
better
have
than
many
2
income
groups.
level.
4 group better than 2 groups depends on situation. Yeah. There's something that only 2 groups cannot. Yeah. Okay. There's something that confirm only 2 groups. Okay. Example, you apply for a job. Okay. Either accept or reject. Okay. Maybe accept KAV the 2 groups. Okay. So you cannot say 2 groups not good, 4 groups is better, not like that. Okay, depends on case by case. But for income level, I would say more group is better. Yeah, because the variation is quite high, variation. But for the job, confirm the outcome must be accept or reject, accept KAV. Okay, let's say for the general election, only 2. Only 2, what do you call? 2 outcome. I mean for the individual candidate. Yeah, so either you win or you lost. That's it. Okay, so
Sorry, sir. Thank you.
yeah, cannot say which one is better. Depends on case by case. Okay, yeah. Okay, so continue. Yeah. So this one done. So now we are here. Okay. So the binary nature of the dependent variable 0, 1 means what? The error term is a binary distribution also. Okay. So therefore, the dependent actually affect the error term. Okay. Remember, we have error term in the multiple linear regression. We also have it in the the logistic. Okay. So yeah, actually should put one more. Yeah, error term. Okay. Yeah. Okay. Therefore, invalidates in all testing based on the assumption of the normality. Okay, means in the multiple linear regression, we must do the test other data, the error term is normal or not normal. But for this case, most probably the error will be not normal. Yeah, they should follow the binomial distribution. Okay, okay. A quick one. Some maybe cannot remember what is a binomial. Okay, binomial. Okay, binomial distribution like this. Yeah, let's say 10 friends. Okay, they are good friends. Therefore, they go for the driving test together. Okay, so driving test. Of course, let's say maybe they just, I'm not sure the age. Maybe 18 now. Maybe 18 years old. Okay, so okay, driving test only two. Kind of other pass or fail. That's it. Okay, I mean the outcome. Yeah. Okay. They learn and then they go for testing. You can outcome can be pass, can be fail. Okay. Let's say based on the past record, the passing rate is 0.85 example. So I mean sorry, the passing rate, yeah, okay, passing rate. Okay, passing rate is 0.85%. Therefore, the probability that each individual will pass the driving test is 0.85. Okay, so here two different two categories. Therefore, it's a binomial. Okay, so means we can find probability that from these 10 people, 10 candidate, at least example, at least 8 of them, yeah, will pass. Yeah, will pass the driving test. Okay, means that's what we can do using the binomial distribution. So it's binomial. Can you see pass or fail? That's it. Okay. So for our case, also the same, means only one or two, one or zero. Let's say the candidate win or lost in the election. Okay, even World Cup also same thing. Okay, some may watch the what they call the game out yesterday. Maybe some out, I don't know. Johor won finally. Okay, so outcome can be two, right? Won or lost. I mean in the final, okay, in the final game. Okay, yeah. So and then okay. The variance of the Thomas variable means here refer to the binary. Okay, refer to the binary. Yeah, binary dependent variable. Okay, therefore the variance is not constant. Okay, it's not constant. Therefore, it's a problem because it creates the heterozygosity. Okay, meaning that some assumption under the multiple linear regression is not made. Okay, because of the binary dependent variable. Okay. Okay, so no question. Now we see. Okay, wait. Okay. Wait, yeah. Okay, interesting. You can convert from MDA to AR when there are only two categories of dependent, but change from categorical to metric. Logistic regression. In the logistic regression, the dependent must be categorical. Okay, must be categorical. Yeah. Okay. Okay, so continue. Yeah, so we are here. Okay. So neither of the above relations can be remediated, yeah, using the transformation of dependent or independent. Means we cannot solve this problem, yeah, using the existing technique, yeah, of the remedial. Okay, cannot. Okay. Okay. Okay, we see a bit on transformation. Sometimes you can do this. Example, you can take a loan. I think discuss a bit. It's okay. I think maybe not this class, but other class. We can transform to loan and then do testing again. Result may be different. Okay. Okay, we call this transformation. Okay. Example, data not normal, you do transformation. Then later the result may be normal. Okay. Yeah. Okay. So therefore, because of this, therefore logistic regression was developed here to specifically deal with these issues. Okay, we see why it's so powerful. Okay. The advantage of logistic regression are primarily the result of the general lack of the assumption. Okay, discussed a bit just now. They cannot meet certain assumptions. Okay. So therefore, logistic regression does not require any specific distributional form for the independent variable. Okay. Therefore, no need to test for the assumption of this. Okay. So hetero also not required because they have different property, okay, different requirement. Okay. So linearity also not required. Okay. Linear relationship between the independent and dependent also not required. Therefore, it's very it's very you can say quite free, quite flexible. Okay, in this logistic. Okay. Okay. So, but again, only two categories here in your dependent. Yeah. Okay. So.
So how about the multi-collinearity? Do we need to test IVs for multi-collinearity?
No need.
Thank you, sir.
No need. Okay. So continue. Yeah. Okay. Okay. Now we want to estimation of logistic. Okay. So transforming the dependent variable. Okay, means referring to the remember 01, 01 or 10 or whatever in the dependent variable. This is a value. Okay. So example 1 means infected COVID before. Yeah, 0 means never. Okay. Example 1 means own the house. 0 means never own the house. Like that. Okay. So we transform it become like this. Okay. Yeah. So we call this odds ratio. Yeah. Okay. So that's what of course we are going to discuss. Okay. Can you see odds ratio? Yeah. Okay. Oh, okay. Don't worry. I can show you. Oh, okay. Okay. It's okay. Yeah. We see first the idea, then we see the output later. Okay. Do some simple calculation. Yeah. Okay. So we can estimate the coefficient, but unfortunately, the this version actually don't have the logistic. Okay, I mean this version that we are doing now cannot do logistic. Okay, so therefore, but therefore I just give you the output. Yeah, using another version. Yeah, and then estimate the output and then use the output for discussion. Also to do the test and the quiz like that. Okay. So, okay. But it's supposed under the what do you call? It's supposed under the regression. Okay, under the regression menu. Okay. Okay, means you click analyze regression, you can find logistic. Okay. Okay. So continue. Yeah. Okay. Okay. So we can estimate it using the software, and then we can transform a probability into odds and also the logic value. Okay, odds means refer to this the odds. Okay, okay. So the logic value means refer to everything, to everything. Okay, but the probability means wait, this is probability. Okay, this is probability. But odds ratio is this. Okay, different thing Okay, again. This is the odds ratio. The whole thing is the logic value. This one is the probability that a person owns a house or infected by COVID before. Okay, three things. Okay. Okay, if no question, now we see next. For this chapter, I think can finish really fast. Okay, we see now. Okay, and then actually this is same thing. Same thing. Yeah. So we estimate the model means is to the also estimate the coefficient together. Okay. Assessing the goodness of fit, of course, use a hit ratio. Okay. Yeah. Okay. If no question, we see next. Yeah.
Sir, coefficient means intercept, right? I guess.
No. Coefficient refer to the beta coefficient.
Oh,
Yeah.
beta. Okay.
Okay. Actually, beta is much more important for us. Alpha not so important. Beta is really important. Okay. Yeah.
So you're saying that SPSS cannot do the logistic regression, right?
Yeah. No, SPSS can do, but the version that we are using cannot.
That's why I saw in regression there's no logistic.
Yeah. So you can click means okay. If you want, you can use the trial version. Yeah, if you want. Yeah, but actually not much important because assignment not going to do logistic, and in the test or exam I will give you the output. Yeah, you just interpret. Okay. Okay. But you
Okay.
suppose. Yeah. Thank you. Okay. Again, you suppose can see it. Wait, not here. I don't want this. So means you suppose can see it when you click analyze. Okay. Okay. Analyze, and then regression, and then you can see logistic. Okay. Yeah. Okay. So we continue. Okay. So now already half. Yeah. Therefore, we need one more class to finish this chapter. Let's see chapter 6. Okay. This chapter 5. Okay. So means 2 more will be cluster and then structural equation modeling. Yeah, 2 more. Okay. So okay. So this one done. This one done. This one done. Yes.
So sir, I mean the way I look at it, logistic regression seems like quite common in real life, right? Because just now you mentioned that SPSS they don't have the logistic regression functionality. So in real life, how to compute how to use how to what kind of software we are using to do this logistic regression?
Okay. No, logistic we can actually SPSS they have, but not this version. Okay. The version that we have actually is you can say it's not complete. Yeah. You can say it's not complete. Okay. So this is optional. Okay. Anyone from here you learn EVS before? Anyone? No. Okay. So I show you first. Since you are okay. Okay. Um, okay. Okay. Anyone use this software before? Anyone? Okay, because it's e-views. Okay. Okay. So this one APU got license. Okay. If you want, you can try to install using the link that given by me that day. Okay. But actually it's not required. Not required for this module. Okay. So we can do logistic using this software. Okay. So quick estimate equation, and then here, can you see binary? Can you see here? Logic. Okay, logic means logistic equation. Okay, here logic. Okay, so therefore, but again, this is not required. Yeah, for this module. Okay, yeah. So therefore, yeah, okay. So therefore, I think it's okay. We focus on the assessment. Yeah, means not going to ask you to do this using the e-views. Okay, yeah. I mean for this chapter. Okay. Yeah.
Just want to ask the e-views and SPSS, which is more powerful at doing what kind of statistic?
Okay, good, very good question. Okay, very good question. Yeah, thank you. Okay. E-view is very good. It's very good and very specified to the economic graduates. Okay, because it's specified. Yeah. Okay, you asked a very good question. Okay, so remember I mentioned that day multiple linear regression. It's okay. Maybe not. It's okay. They extend to few areas. Okay, one is the MDA. Yeah, here is multi-level. Okay, we are offering this module for data science student. Okay, so multi-level data analysis, and then after this is XEM. Means from one dependent become two dependent. Okay, and also include mediating all these things. This one we are going to discuss in the last chapter. In the last last chapter. Right. So another one is like econometric. Okay. So econometric is basically is using by the economic graduates. Now also finance okay. Economic and also finance students. So therefore, some of you maybe use this before in your degree. Maybe I'm not sure. Okay. Yeah. For APU banking student, they also learn this module. Yeah, that's why I have this software. Okay, I taught this module before. Okay, yeah, about a few years ago. Yeah, okay. So therefore, it's very good to analyze econometric model, more to economic data. Okay, and I can say it's really powerful to handle the time series data, time series, and also the panel data. Okay, so for the SPSS, yeah, I mean e-views e-views are very good to handle this. SPSS is very good to handle the what do you call the wait primary, okay, primary data. Yeah, I mean SPSS also can handle time series, but e-view is much more powerful. Yeah, e-views also can handle the primary data, but SPSS is much more powerful. Like that. Okay, yeah. So that's the difference, okay, between these two. Maybe some basic one. Example, e-views cannot do multiple discriminant. Okay. For this module, still using the SPSS is much more appropriate for this module. Yeah. Okay. Yeah.
Okay.
Okay. So continue. Yeah. Okay. 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 You can see almost slide. No problem. Okay. Okay. So we are here. Yeah. Okay. Okay. I think maybe not, maybe not. Because to discuss the difference, okay, between maximum likelihood and least square also another 10 minutes. It's okay. This one next class lah. Okay, next class. Okay. Yeah, you do planning for next class. Wait, next class. Next class will be 14. Is it anyone? Yeah, I think so. I think so. Nah, yeah, okay. So no more weekend class. Next class will be weekday 14. Therefore, we use we start at 7:30. Okay, 7:30 until 9:30. Okay. Okay. But based on the planning, also emphasis by you, one of your friend that day. I think we follow this one. Means next class will be the assignment clinic, correct? Next class will be the assignment clinic. Okay, we see the timetable. Yes, correct. Okay, you follow. Okay. So means you ask many questions as possible. Okay, about the assignment in the next class. Okay. Okay. Again, I mentioned that day. I mentioned just now also. This you can depends on you. You decide later. You also can use this to do the test. Yeah, up to you. I mean, if we can vote later. Okay, see how in the previous intake, we also voted. Okay, we also voted. Some students want to use the exam date to do test, but some don't want. Finally, use the reading class. But for you, it's okay. We can vote later. Let's see how. Okay. So, okay. I think we cannot decide the date for the test. The quiz one, yeah, cannot. Okay. Maybe next class lah. We see how. Yeah. Okay. Any question? Yes. For today. Yeah. Okay. So if no, see you on Wednesday. Yeah. Thank you.
Thank you. See you, sir.
Okay. See you. Thank you.